Hi, welcome to part 9 of the video series about laws of motion. In the previous two videos, we have solved some examples related to the universal law of gravity. In this video, we are going to define the normal force. There is no specific formula which we can use to calculate the normal force. We have to calculate it depending on the question. In this video, we are going to see the three simplest cases. The normal force is the force exerted by the surface on an object in contact with it. It is acting perpendicular to the surface, irrespective of whether the plane is horizontal or inclined. The phrase normal in this instance is used in the geometric sense and means perpendicular, as opposed to the common languages of normal meaning ordinary or expected. We have stated that normal force is always perpendicular to the surface, so let's see how we can draw it depending on the surface. In the first diagram, an object is on a horizontal surface. To represent the normal force, we draw a vector which starts at surface and acts towards the object. In the second diagram, the object stands on an inclined surface. The normal force is the vector which starts at surface, perpendicular to it, and which is drawn towards the object. In the third diagram, the object is standing or sliding on a surface which is in a vertical direction. In this case, the normal force will be in horizontal direction, as it must be perpendicular to the surface. In the last diagram, the object is touching the ceiling. A magnet attached to a metallic ceiling can be an example for this case. Again, the vector representing the normal force starts at surface and points towards the object. At the same time, it is perpendicular to the surface. Calculating the value of the normal force can differ depending on the type of the question. In this video, we are going to learn how to calculate it for the easiest three cases. In first example, an object of mass of 5 kgs stands on a horizontal surface. The task is to calculate the normal force applied on this object. As usual, for most of questions in laws of motion, we start our solution by drawing a free body diagram for a given object. There are two forces applied on the object on the figure. Force of gravity is acting downwards, and the normal force is acting upwards from surface towards the object. The object is in equilibrium, at least for the vertical axis. The reason we say at least in vertical axis is that the normal force is in vertical direction. So while calculating it, we will deal with vertical forces only, or the forces which are parallel to it. If we choose upwards as a positive direction and downward as a negative one, the normal force will have positive value and the gravitational force will have a negative one. Force of gravity is equal to mass times gravitational acceleration, which are 5 kgs and 9.8 meters per second square respectively. The normal force is equal to 49 newtons. In the second case, we have same object on the same surface. It is experiencing one extra force, a force of 10 newtons which is pressing the object to the surface. As usual, let's start the solution by drawing a free body diagram. First two forces in the diagram are same as in the previous question. The force of gravity is downwards and the normal force is upwards. The last force is the force shown in the figure in the question. A force of 10 newtons applied downwards. Again, while calculating the normal force, we only consider the forces which are parallel to it. If we choose upward as a positive direction, the normal force will have positive value, force of gravity and applied force will get a negative one. Force of gravity can be calculated by multiplying the mass of the object and the gravitational acceleration. Mass is 5 kilograms, gravitational acceleration is 9.8 meters per second square, and the applied force is 10 newtons. The normal force for this question is going to be equal to 59 newtons. The last example of this video is very similar to the second one. The only difference is the direction of the applied force. In a free body diagram, we draw the force of gravity and the normal force as usual. For applied force, we will just swap its direction. Instead of drawing it downwards, now we will draw it upwards. As a result, in the equation, it will have a positive value as opposed to its value in the previous question. So, the equation becomes normal force plus 10 minus 5 times 9.8, and it is equal to 39 newtons. In this video, we had defined the normal force and learned how to calculate it for 3 different cases. In the next video, we are going to learn how to calculate the normal force for more complicated cases. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.